on the bench today we've got this flash for flash photography. This is, I think, about 1970s vintage. Might be a little bit earlier, but it's a nice sturdy unit. It looks very nice. Excuse that, I already loosened the screws on this. But I'd really like to repair this, especially because this has internal rechargeable batteries, so you don't need to stuff a handful of AA's down the thing every time you take it out. Because these are fairly power hungry. And I think if I look at this is in fairly good condition. If we get this apart, and I think if we give it a recap and put a new battery in, this should be fine. It's probably NiCad though. We'll just see what we do with that. So I already had this apart. How you take it apart is you loosen those two screws, and then these pop out, and then there's about 1,500 plastic bits that fall out. And you do the same thing for the front. But there's this pin. You basically have to you're supposed to push it out like this. This does not want to come apart today. Well, I'll be back in a second. So I finally got it apart. There's more plastic bits coming off, but now that you have that, you can actually lift this out. And this is where the battery sits. It's weird form factor for a battery, but I'm also almost certain that this capacitor here is bad, so we've also got to change that. And I'll begin with just cutting out this battery here. Which doesn't tell us anything about the voltage and or the current rating, but well, this was the top pin. It was welded onto here. I think this is just large coin cell batteries stacked up. So I'll just open this and that's probably cadmium salts. Yeah, I don't want to open this up any further. Well, maybe a little. So yeah, these are stacked up like this. This would be 1, 2, 3, 4 cells. So it's 4 times 1.5, which would likely make this about a 6-volt unit. I think the next thing I'll do is I'll just turn it on and see what it does. Stick 6 volts across it. Current limit it down a little bit. It doesn't blow itself up. In case the capacitor is bad. Now we also should do is check which of these is ground. Don't necessarily want to take this apart any more than I already have. I don't think I have much of a choice, but the nice thing is there's an electrolytic capacitor sitting down there that we can take off a measurement and see what ground on that capacitor is connected to. There's a good chance that capacitor is actually, the negative terminal on this is actually connected to ground. Yeah, it doesn't connect to that one. Great. So this top lug here, and what's with the lighting? That's just as bad. No, that looks terrible. This is a little better now. So this is positive, and this is negative. Just plug it in and see where we get. So you should be warned, there's high voltage all over this thing. Oh, but I hear it humming. It's probably not the worst sign. Yeah, this is switched on, but obviously it doesn't charge up properly because the electrolytic is dead, but at least it is doing that. Yeah, this is actually sucking in 12 watts from the power supply. I think this is definitely shorted. That electrolytic is almost certainly bad. So, well, I think there's no other way than to just take all of that stuff out. I didn't want to do that. Yeah. see if I can get that back together after I'm done with it. So what I'll do is I'll desolder this large electrolytic capacitor. What's actually interesting about this is it has a large germanium transistor down there, and this fin is actually a heatsink that is just wrapped around it. That is ingenious. I like that. The electrolytic here is a 900 at 360 volts. It's actually quite large. For now, I'll just put 47 at 400 in, just to see if we can make the thing work. And if it actually works, I'll order. I don't have these large value electrolytics in stock. A little bit of an oddball value too. So if that should work, I will order a replacement. So what is connected to what? The red is connected to positive and the black is connected to negative. Yeah, this doesn't want to. Well, I think that's not a thing that I'll do off camera. I actually got the electrolytic out after a little bit of persuasion. Going to do now is just tag this in here. Like so. And then we'll just check if it works. Because while this is pretty neat in terms of construction, I will not spend a lot of time on repairing this. If this doesn't work after switching a couple of capacitors, the transformer is blown or something, I will not try and repair it. So this, I think, goes over here. This is pretty serviceable, but they packed it into the case so tightly. It's not all that much fun to repair. these two connect over here somewhere. So let's just feed it some power and see what it does. This is ground over here, and this should be the positive terminal that goes to the switch. Oh yeah, that sounds healthy. So let me just try and test this without getting myself shocked. Oh yeah. Snap, crackle and pop. We have a winner. Nice. So I'll just put the whole electronics package over here. Yeah, this seems to work just about fine. I still need to order a largest capacitor for this. No, just for a bit of fun. Let's just test if this is completely shorted at a volt or so. Usually those capacitors, they fail in a way that they will start leaking at a couple hundred volts. Yeah, there's nothing there. But if I put, let's actually do that. If I would put 10 or 20 volts on there, I'm almost certain it would start passing a lot of current. Now let's just plug that in here. No? Well, I've got 100 milliamps at 12 volts. Which, that would be enough to bring this high voltage line down. I'll also just swap this capacitor up here. This is probably not as critical. There's another one down here, another one down here. I'm not sure if I want to go in there and swap them. This is 1000 at 6.3. I will replace that by 1000 at 16. That should be more than good enough. I'll actually cut down the leads a little. Maybe I can even fit it. Yeah, that should work. If I bend these out like this. Yeah, it looks good to me. Just hope I can still fit this in its clamshell case here after I'm done. Buried in there, all the way down, there's a 4.7. So how would I get that out? So I think I'll just try lift it out from below. This one? Don't think so. Oh yeah, it is. There we go. Yeah, and that's the other one. There we go. This is a 4.7 at 250 volts. I think I actually have something that would fit in there. Looks like I actually don't. At least I don't have anything the right size to fit in there. But what I have is a 1 micro. The one was 4.7, 250. Well, it's probably just a timing cap. I don't know, I think I'll just parallel up 2 of those. No, I actually also have a 10 at 350. I think I'll put that in there and we'll see if it runs any better or worse. I think this is likely what it could be is these devices usually use what they call a trigger transformer, and they discharge a smaller capacitor into this transformer to generate the pulse that actually triggers the flash bulb. It makes it arc over. And I think this might be this, might actually be the capacitor that gets discharged into that transformer. So, yeah. Values are probably really uncritical. I'll just stick to 10 in there, and we'll see. Still runs satisfactorily. I just sort all my wires back here. And then hook it back up to power. Right, this is positive. And we'll set that at 6 volts, 1 amp. I think it sounds a little different. Well, I thought about that before I started. Oh, but what I can do is I can just short out those 2 contacts and that should trigger it. Well, I'll just power it down here. This is very likely still charged. I'll just get myself a clip lead. No, this doesn't seem to trigger it. Oh, there we go. Smallish flash, but no, that seems to work. Tube in this, the discharge lamp sounds really aggressive. It's really snappy. Don't know if that is actually something that's supposed to happen. Well, it's supposed to be like that, but last capacitor, this one here. Let's just hope this one is not another sort of oddball value that I don't have. This is 1 at 35. That I can easily replace. And what I'll put in is a 1 at 63. A little bit overrated, but it will do alright. Oh, come on. This is it all recapped. Let's try for a third time as if it still works. Yeah, that seems to work just fine. The contact is not all that great, but yeah, that works. So I'll try and replace that cap, and I'll think about what I'll do to the battery. But then we have that thing back on its feet. I made myself a battery pack, which is just 4 AAA cells, nickel metal hydride cells, stacked together and then just spot welded or soldered into a pack. And this is actually a lot smaller than the other one, although it is a little longer, so I hope I can fit it in. In terms of capacity, this is probably... Oh, crap. I just broke the tab off. This is probably a little worse, although this is nickel metal hydride, and the other cells are very, very likely nickel cadmium. So might just work well enough. There we go. Just soldered it back on. Now I'll just remove the sleeves here. And just desolder this from the old lugs. Or I could just as well just spot weld those tabs on there. But since I already put some solder onto these battery contacts, I'll just solder them on. Soldering to battery terminals is something you should not do. You'll very, very likely damage the battery, at least a little bit. But yeah, this is just making something work again, and if the batteries die in a month, I know how to fix them. Oh, yeah, I forgot to switch it off. This doesn't want to melt. Oh, now it goes. There's another one of those tabs broken off because it just worked. Then it suddenly stopped. Maybe these batteries are just depleted. I mean, that is a possibility. Ow. Yeah, I just gave myself a little shock there. So yeah, why isn't this working? I suspect the batteries are probably depleted. It just as well might be a broken tab or something. No, there's. Yeah, it's probably a contact that is broken because I'm not getting any. Yeah, there it is. That's why it's not working. Yeah, this one is also broken. Yeah, now it should be fine. Right. So far, so good. I think what I'll do now is I'll check my box of various capacitors of various sizes for something that will replace this. And once I've done that, can actually see if we can get it all back together. So I found a capacitor that could replace this, which is 1000 at 300 volts. I have a box of those. But this has a higher voltage rating. So what we'll have to do now is look at the capacitor we put in there and see, is it actually going up to 360 volts? Or is that just something they put in there because it was cheap and the next value to what they actually wanted? Yeah. This is charging up to exactly 360 volts. That is unfortunately what I expected. Since I really don't want to order one of those, like a 900 at 360 or 1000 at 360, let me just see if I can maybe clamp the voltage down a little to 300 and to 300 exactly. Because this is how much this can take, and we'll see if it still works then. So the next thing I did is I put 2 Zener diodes over the capacitor, so it limits it to about 300 volts. That should be alright. What I also did is I changed those 2 capacitors here, because this one here, which is a mica, they're not known to fail, but when I was testing it, the thing just exploded in a huge bang. I hope this one is a lot larger than the capacitor that was in here before. I just hope I can still fit it all in the envelope. So that's what I'm trying to do next, is put this all back together